About our company, Fujifilm Inkjet Solutions Group. We're a global manufacturer of inkjet inks and pigment dispersions. We work with brand owners and OEMs and also internally. So we've got a wide range of digital and analogue solutions to meet application requirements. Mark, anything to add about yourself?
No, I think it's all been said.
Okay, so go analogue, go digital. Well, we're not here to tell you whether your process should be analogue or digital. You know what you need, and it's based on your unique requirements. It could be something that we can't consider, like your factory footprint or your cost considerations. But we do fundamentally and passionately believe, as ink designers, that ink chemistry is critical to success, whatever your application. So we're here today to give you a toolbox of questions that you can consider in relation to your process that will allow you to get the best chance of success, whatever your method of production, analogue or digital. So please take your time. Really think about your application, key to everything. And when we're talking about industrial applications, we can see from the audience and the stands outside that there are so many. It's not like other printing processes, for example, graphics, where today you can almost think about what you want to do and buy something off the shelf. So everything we're going to talk about really is linked to application. Think about what your application requires. Because you could have the most cost-effective process, but if the product doesn't do what your customer needs it to do, you know it's not going to sell. And as I said, we believe ink chemistry is key to this success. We're going to look at one individual application just to illustrate that by way of introduction. And the one we've picked is interior decor. So if you think about ink chemistry, why is it critical here? Look at some of the examples. Imagine you've just paid €1,000 for your laminate flooring in your lovely new bedroom or kitchen or living space. And you're inviting your friends round, and suddenly you notice that as the months have gone by, it started off a nice brown here. It's still a nice brown there, but it's yellow over here where your pigment's faded because of the light from the window. So we make sure with the ink chemistry we're getting the pigment right for that application. As a printer, think how you've made that laminate. You might have decided to use a surface printing process, maybe inkjet. Ink then has got to have a robustness to deal with that scuff as people walk on it. So again, you might pick a UV ink chemistry. Alternatively, you might have decided to make that laminate flooring printing as part of the lamination process, so your print is encapsulated within the multi-layer laminate. In that case, you might choose an aqueous technology that gives you a nice low film bead and allows you to have that good interlayer bonding. And then think, just another example, some of the soft feel fabrics there. Don't you think it's nice to feel something soft and tactile? Again, your choice of ink chemistry is going to allow you to achieve that. So the first thing we're going to look at is why ink chemistry is critical. The second thing is the system. So we're going to look again, digital and analogue, they've both got great strengths as industrial printing systems. We're going to look at some of the commonalities, but we're mainly going to focus there on the differences between digital and analogue processes. And again, great technologies, we're going to focus on some of the critical aspects that you need to consider to make sure you've got your ink robustly transmitted to your product. And then the third thing we're going to consider is optimisation. Optimisation really is about getting the thing to work together. This is where you get your added benefit. You really get your ink, your system working together, and then making it right for your process. So as I said, in terms of the process, application is key. Think of your application. We're going to talk through ink chemistry, system, and optimisation. And with the optimisation stage, we're going to run through a little case study to illustrate the point. So I'll hand over to Mark for the most technical aspect of the presentation, why we believe ink chemistry is fundamental to achieving your application success.
Okay, thanks, Ange. So for surface coatings, the general rule of thumb is that like will adhere to like. This means that the resin you choose should work with your, give the best results for your substrate while giving optimal performance properties and meeting any other customer requirements. There are several different chemistries which we may choose, whether using analogue or digital printing. And each of these will have benefits and drawbacks. For digital inks, a major constraint upon what we choose is viscosity, which is dependent upon the print head for the machine that we use. For analog, this is less of an issue because whatever technology we use, there's going to be a print head or a print method that can carry it. So first of all, aqueous inks, generally, they're very environmentally friendly. They're not really made from oil, very small amounts, and they don't contain high levels of VOCs. They're relatively sustainable, although they do use a large amount of water in the manufacture. But they do need quite high temperatures to cure once you printed them, and that can be quite unfriendly in terms of the environment. You've got to first drive off the water so that the film can coalesce, and then you've got to give it more temperature to fully cure it. And after that point, you get your full resistance properties. They will dry at room temperature or just above, but if you do that, it's going to take a long time to cure, and you may struggle to get your full resistance properties. Infrared dryers tend to be quite inefficient, maybe, I don't know, 50% at most. There are more efficient dryers coming up, so that's a reason why they're not very efficient in terms of the environment. And it can be quite hard to get adhesion to plastics with water-based inks. There's a limited choice of resins that are available, okay? You can use catalysts to increase the adhesion. For analog, that's not an issue. For digital, they need to be blocked, because otherwise you can't boast add. Now, when aqueous inks are screen printed, we tend to get something called drying in, poor screen stability, and you get something quite similar for other ink technologies as well. So in Flexo, you can get filled cells, filled analog cells, and with digital, you can get blocked nozzles. So what we do is we add humectants, which are chemicals which hold the water in the film, but these can then cause problems with drying. So it's a very fine balance between drying too quickly, drying too slowly. So we need something to hit the sweet spot in the middle. So we then quite often use co-solvents, and these help us control the drying. Now, the image quality for water-based inks is generally very good, and especially if we use co-solvents. These help to keep the mesh open, give very good screen stability or very good definition. And when they're fully cured, they're almost bulletproof. They're very hard to redissolve. So chemical resistance is generally excellent with water-based inks. And that's especially if you use a catalyst. Solvent-based inks, most solvents are made from or refined from oil. They're not very environmentally friendly. And also, they contain high levels of VOCs, which are damaging to the environment. But they do contain or they can contain many different resin types, which gives you a very wide adhesion range, especially if you increase this with a catalyst or a cross-linked resin. So the choice of solvent is really dependent upon the resin type that you use. Like I've said, like tends to go with like, and that's true for solvents as well as resins. But some of the higher resistance properties, you need specialist resins, and these can then be quite hard to dissolve. So you need some quite strong solvents to dissolve these. And that can cause problems later on with VOC emissions or whatever. And they also require temperatures to fully cure them. Okay, you've got to drive all these solvents off, so that's quite energy inefficient, and also it generates a lot of VOCs, which you need to vent out, hopefully with filtration to get rid of it. So they're not very environmentally friendly in terms of composition or application. But since there's a wide range of resins, there's quite a wide adhesion for solvent-based inks. And catalysts can increase that quite dramatically. But again, for digital, that's not an option unless they're blocked. Image quality is generally very good, but that's dependent upon the resin type being used. But chemical resistance isn't always acceptable unless you're using catalysts. The raw materials for UV inks aren't very environmentally friendly because quite often they're made from oil, although that is changing and a lot more sustainable materials are coming into fashion now. But there's generally no VOCs in them. But in terms of application, they are very environmentally friendly. UV dryers use a lot less energy than infrared, and also there's no generation or very little generation of heat or other wasteful byproducts. Okay, especially if you're using LED. And they've got infinite open time, which means that they don't dry in either in the screen or the analogues or the nozzle. So they will be permanently open unless they get UV light of the right wavelength and intensity to cure them. They're going to be fully cured pretty much instantly. I mean, there is a post-hardening process, but that's really just the icing on the cake. 90% of the curing is done as quick as that. Okay. So basically, the monomers attack the surface of the substrate. That carries the resin in. It gets a quick blast of UV. That cross-links it straight away. There is quite a limited resin choice of UV reactive oligomers. But the way they work, they give very good adhesion, especially with catalysts, which can have adhesion to very difficult substrates. And that's because UV inks give excellent chemical resistance because they're fully cross-linked almost instantly. Hybrid systems have reasonable environmental impact. They contain both solvent and UV. So the solvent bits can be either made from oil or not. But the UV almost certainly is. But they don't contain many VOCs. But in application, they've got a lot lower impact than solvent-based inks, although not quite as good as UV. Basically, you'd heat them to remove the solvent and then give them a UV cure to finish them off. The volatile materials also give increased adhesion to some quite difficult substrates, so they improve the adhesion compared to UV inks. And then once the volatile's gone, you get much lower film weights than with conventional UV. So they give benefits compared to both UV and solvent-based inks. So you get a reduced film weight due to the lower volatile materials, but improved adhesion compared to conventional UV. And because they're UV cured, you get the chemical resistance of UV cured inks as well.
Thanks, Mark. That's very comprehensive. So you can see why ink chemistry is critical to getting your application right. Once you've considered your chemistry, the second step is the system needs. We've got to marry the ink and the system together so that your core technology is robustly delivered to the printed product. And if you think about it, there's lots of components in a system. Print head, screen. Ink is just one of those components. But ink is the only part of your system that ends up in your final product. So let's take a look at some of the things to consider for both analog and digital processes. And Mark, do you want to kick off with the analog?
Artwork's generated using a computer to split the image into several colours. Each of these colours is then printed using a photo-opaque ink onto a clear substrate to generate positives. Now, these positives are then used to create either screens or plates. Screens can be used straight away, more or less. Plates need to be fixed to a roller, which needs to be put onto the machine before printing. Okay, now that's quite a time-consuming process, which means that for very short runs, it's not cost-effective. But for longer runs, the costs are pretty much negligible. Now, once you've got your screens or plates, then analog printing it's an impact process. The ink is basically dropped directly onto the substrate. So with screen printing, a squeegee drops onto the substrate, and it then pushes the ink through the mesh onto the substrate, and then as it goes past, the ink, the mesh moves away, leaves the ink directly on the substrate. The mesh and stencil thickness determine the film weight, which can be anything from about 10 microns to 100 microns. In flexo printing, a roller collects ink from a duct and puts it onto an Analogue roller with stick into it. These then go onto an image roller, and they go directly onto a substrate. The Analogue etching determines the film weight, which can be anything from about 2 to 6 microns, so very low film weights indeed. There's a wide range of chemistries possible using Analogue, because basically there's whatever viscosity you've got, there'll be some form of Analogue printing that can print it. So flexo inks, they're very thin and free-flowing, whereas textile inks they can be anything from water-based inks, which are quite low viscosity, up to plastisols, which are almost solid. Litho inks are extremely thick gels. So it's possible to produce prints with adhesion to almost any substrate using an analog process. But if you want very high detailed images, then the very thick inks are unlikely to be able to print it. So you may need to adapt your artwork slightly. Okay.
For digital printing, we've got some very similar considerations. So again, you've got to think about your system, your productivity, particularly in a single pass application, matching your ink cure speed or drying speed to the productivity you require and the hardware, therefore, you need for that. We also have similar but different considerations. For example, how do you keep your press running reliably throughout your print run? And again, in your case, Mark, it might be keeping those screens open or those rollers in the right condition. For us, it's keeping that print head effectively jetting drops. But the big difference, I think, for me, does come from the print head. When you think about it now, we're working with print heads that can be the size of your thumb with thousands, multiple thousands of nozzles packed into that space. Those nozzles can be half the size of a human hair. They can be firing at up to 100 kilohertz, small drops, 2 picoliter drops, reliably out of the head. And that's the inkjet challenge. So Mark mentioned viscosity. Obviously, to get ink flowing through those very tiny channels to reach each of those tiny nozzles, we need a very low viscosity. So we need to think about your application's functional requirements and make sure that we can build that in to the ink at that low viscosity. Also, the ink's got to have a very low particle size. We can't have those nozzles being blocked by agglomerates of pigment as it goes through the various channels. So that's a key technology feature we need to build into our inkjet inks. And then also, we're trying to develop an ink that is ejected through that nozzle as a perfect drop. It knows how to actually form a drop, to leave the bulk of the ink, to fly through the air without disintegrating into lots of smaller that are going to give you image quality issues. And then when it reaches the substrate, we're going to say, actually, we don't want you to be a drop anymore. We want you to spread out. And all of these things can be balanced by matching the ink to the system. So your print head selection, your hardware selection. That brings us on to the third aspect, and that's the optimization. And this is the really exciting bit for your application, because this is where you take something and make it special. There's lots of things we can do, both in terms of analog and in terms of digital. So what are some of the analog tricks, Mark?
So with analog systems, there are a wide range of effects and inks which can be achieved as long as these meet the specific job requirements of the customer. For example, we've got high-speed opaque whites, which we use for flexo inks. They've got adhesion to a wide range of substrates and can be printed at higher web speeds than digital inks can. So they can be used to make a base on which to print other colours. We've got primers that can help to give adhesion to a wider range of substrates than you can normally print. Adhesion can also be improved by use of corona treatment for particularly difficult substrates. But if you're using a hybrid system, then print speeds for analog tend to be quite a lot higher than digital ones. So if you're printing a hybrid system, you've got the capacity to slow the machine down, print it at the optimum for the digital print, and then you're giving the analog print better cure, which can help improve adhesion or resistance. Now in analog, we've also got a wide range of special effects, such as varnishes and adhesives, as well as a very wide range of colours. Now, most of our ink ranges have got Pantone matching systems, so there's 10 to 15 colours there. By mixing these colours, you can get thousands of other colours. And this gives you, like I say, a whole range of colours. But as well as that, we've got specialist colours like metallics or pearlescence or high-build varnishes were mentioned earlier on. So we've got quite a wide range of effects that we can use. Each of these systems got optimal conditions for use. We give a PI sheet to say what those conditions are for each particular range. For example, if it's a screen range, then we'll tell you the ideal mesh count for it, and curing conditions if it's a flexo range, ideal analogues is for each particular colour. If you're running a job and you find that you need to slow it down, then there may be some movement on those. Those are based on the ideal, but you might find that you need to modify things to give slightly better performance for your particular application. What's important is that you run a pre-production job just to make sure that the ink works, get it to work as you want before you go into full production. If you're doing something in the industrial workspace, you'd really need to make sure that the job works properly before you run it. Okay, so pre-proofing is very important.
For digital printing, you might want to consider waveform optimization, how you actually drive that print head. So your substrate might be irregular. You might need a higher throw height. So you can manipulate that waveform to give you the right drop velocity, to give you the placement for the image quality you need. Or you might also have a wide range of substrates you want to print on with different energies of the substrate. So you can optimize your ink and your hardware for pinning those drops, so you get the right drop spread on each different substrate. I think a good way to illustrate this is a case study, Mark. So here we have a hybrid print system. What's our application? We want to print labels. So what's the chemistry? It needs to be durable. It needs to have a glossy finish. Our target substrates are polypropylenes, polyethylenes. We selected a UV ink chemistry for this because it has a range and it will give us that durable, glossy finish. Then we looked at the system considerations. We need variable data. We need to change the information on the back of the label in a variety of languages, for example. We also need some metallic inks and some speciality coatings to make this product really stand out, to really fly off the shelf. So this led us to a hybrid system. So we've said go analog, go digital. It might be you want to go both. So we have here some flexo pre-printing stations. Maybe we want to do a high-speed white. And then we've got the post-print for metallics or high build varnishes. The optimization comes in where we're looking at really optimizing the ink and the print head to get that high image quality in the digital part of the process, and also aligning both the flexo and the digital processes to give us that single pass matched high speed performance. So I think in summary, I'd just like to say, right from the start, application is key. Once you've really considered your application, what you need to build into your product in terms of its printed functionality, then look at your ink chemistry. As we said right at the start, hopefully you've seen how critical this is to do right up front. Then once you've settled on your ink chemistry, look at your system design, again, with innovation in mind. And then finally, that optimization, the really exciting part where you really get your product to do what you want to do and get your competitive advantage. So again, as we said at the start, we understand there's many, many industrial applications, and that's why we've got the team with us here today and tomorrow. And if you'd like to visit us on our tabletop, we'd be happy to discuss your individual requirements.